Yeah, due to connection, again, technical errors. So I'll just take it from here. So yeah, I was here. In this case, we were simplifying, right? And then we figured that 3 cos squared x plus 3 sine squared x. This, it is the identity, right? It is identity cos squared x plus sine squared x. It will give us 1. But since when we have 3 over here, that will be 1 multiplied by 3. And so I just decided to write 3 over here. And then that minus 1, it is this one over here. And therefore 3 minus 1, that will give us 2 divided by 2 cos squared x, and therefore 2 will cancel 2. We are left with 1 over cos squared x. Then now we can conclude by saying, therefore, if you have a look at this, is the same as that. Therefore, the left-hand side is equals to the right-hand side. Okay, so that's how we prove this identity. And then 5.5.2, it says to us, for which value or values of x, x is the element of the set from 0 to 360 degrees, will the identity be undefined? Will the identity be undefined? So for something to be undefined, it's when we have a fraction, right, at this point in time. It's when we have a fraction, and then that fraction, the denominator, we do have 0, right? So in order for us to do that, we can take this or we can take this. But by the way, this and this will most definitely give us the same situation. So remember, if you have 1 over, let's say we say cos squared x is equals to 0, right? If this thing is equals to 0, then in the position of this, we will write 0. So 1 divided by 0, this will be undefined, right? So right. So now what we're going to do is we're going to take this expression at the denominator over here, right? Right. We're going to equate that expression to 0 and try to solve for x, because the value of x that we're going to get and we substitute it over here, it is the one that will help us to formulate this expression to be 0. So 5.5.2, we're going to take our cos squared x and equate that to 0, and then we solve for x. So cos squared x is equals to 0. Let's solve for x. Take root sign on both sides. We have cos x is equals to square root of 0 is going to be 0. And then x is equals to second function of cos 0. What is the second function of cos 0? In this case, you're going to get 90 degrees. 90 degrees plus k, this is cos, multiplied by 360 degrees, right? Whereby k is the element of all integers. So this will be your reference angle. So remember, when we're going to take it from here, here, because it is neither positive nor negative, it is neutral, right? So meaning we're going to consider all of the quadrants. When we have 0, we consider all of the quadrants, meaning we consider quadrant 3, 2, we consider quadrant 3, we consider quadrant 4. So in quadrant 2, in quadrant 3, we're going to have what? So let's start with 2. Quadrant 2. In quadrant 2, we have 180 degrees. By the way, it's not necessary for if, but you know what, do it, it's okay. Quadrant 2, we have, because you're going to get the same answer, but it's fine, do it. So in quadrant 2, 180 minus, we're going to minus our reference angle. We're going to have x this side, which is that, and then minus 90 degrees plus 360 degrees times k, whereby k is the element of integers. So here our x will be equals to how much? 180 minus 90. You see, you still do get the same answer as that one. But if you practice more often, you would see that it's not necessary for you to do this one. You can do it, it's not wrong, just that, yeah. And then now we go to quadrant 3. Quadrant 3, we know that it is 180 degrees plus, right? 180 degrees plus, we make use of our reference angle. This side is x, this side is 90 degrees plus 360 degrees times k, whereby k is the element of integers. Therefore, 180 plus 90, this one will give us 270 degrees, right? And then we still use quadrant 4. But again, it's unnecessary for you. Let's do it, it's okay? And then you can also do quadrant 4, whereby you're going to say it's 360 degrees minus. Quadrant 4 is 360 degrees minus our reference angle x, 90 degrees plus 360 degrees times k, whereby k is the element of integers. So here, okay, so 360 minus 90, it will still give you 270. You see, it's unnecessary for you to write it because you got it here. Plus 360 degrees times k. So this is another solution. So the first solution, it is this one. We don't have to highlight that one because it's the same. The second solution, it is this one, where we get, but again, 90. Even from the reference angle, we still do have 90. So basically, you didn't have to do your second quadrant. You didn't have to do this. It's unnecessary, and this one, it is unnecessary. The only one that is correct is this for you, because 270 is only here. But here, the reason why I'm saying you can't do this is because it's already here. The reason why I'm saying you can't do this is because it's already here. So either way, but it's fine. There's nothing wrong that you did over here. If maybe you want to do it like this, you're still gonna get your complete marks. But I want you to do it like this because you guys sometimes don't do things fully. So get used to do it like this. When you see 0, you focus in all of the quadrants. But when you see negative something, you go to the negative, whatever your function is negative. When you see positive something, but when you see 0, you focus in all quadrants because 0 is neutral. You can't say 0 is positive or negative. 0 is just a neutral number, okay? So yeah, that's how we go about for this question, which is 5.5.2.